Let's work through an example in which I show how to find the equation of a cubic polynomial from its graph. So as you can see here, I'm drawing an xy grid, so that's the x-axis and the y-axis. And let's say that as we go from left to right, our cubic polynomial's curve does this. It increases, crosses the x-axis, crosses the y-axis, goes back down, crosses the x-axis, then shoots back up and crosses the x-axis again, and goes on forever. And in fact, to show that it goes on forever, I can draw a small arrow on the left-hand side here pointing downwards, and the arrow pointing upwards on the right-hand side. I'll also add that this curve crosses the x-axis at -1, at 2, and at 3, and it crosses the y-axis at 18. Okay, so this is the cubic whose equation we need to find. Well, since it's a cubic polynomial, we know that in standard form, its equation has to look like this. Y equals to ax cubed plus bx squared plus cx plus d. And so to find its equation in standard form, we'll need 4 coefficients, a, b, c, and d. But rather than aiming for the standard form of this polynomial's equation, we use the graph we have here to write the equation in its factored form, or its factorized form. And here's how that works. Looking at this curve here, and in particular the values of x at which it crosses the x-axis, we can go ahead and state that its equation in factored form looks something like this. Y equals to a times, in parentheses, x minus -1, and I'll just write that in parentheses, so that's -1, times x minus 2. So I'll write that here, that's 2, and I close the parentheses, and that multiplies x minus 3. And I'll write that here, done. Notice that in each of these pairs of parentheses, the number being subtracted from the x is a value of x at which the curve crosses the x-axis. Furthermore, looking at this first pair of parentheses, since we're subtracting a -1 from the x, this turns into x plus 1. And in fact, I'll write that underneath. We have y equals to a times x plus 1 times x minus 2 times x minus 3. And I'll go ahead and box that intermediate result. There we go. Each of the pairs of parentheses that we have here is known as a linear factor of our function. And when we write a polynomial's equation in this way, we say that we're writing it in its factored form, or its factorized form, or even its root factored form. And the advantage of doing this is that rather than having 4 coefficients, a, b, c, and d to find, all we have to find is the leading coefficient a. In other words, we've gone from 4 unknown coefficients to just 1. And so how do we find a? Well, to begin with, we notice that as we go from left to right along this curve, it's an increasing cubic polynomial. Indeed, if we were to carry on past x equals to 3 here, the curve would go up forever. In a similar way, if we were to go to the left of -1 here, the curve would go downwards forever. And that's worth keeping in mind. That is, when the leading coefficient a of a cubic polynomial is positive, then as we go from left to right, the curve increases, something like this. So that would be a greater than 0. On the other hand, if the leading coefficient a were negative, then as we'd go from left to right, it would be a decreasing function, something like that. And that would be a negative. So just from the curve here, we know that a has to be positive, but what's its actual value? Well, to find its value, we can use the x and y coordinates of any point along the curve's length other than the 3 x-intercepts we've just used. Looking at the curve here, we notice that we're given the y-intercept, and I should say that will often be the case. Indeed, we can see that this curve crosses the y-axis when y equals to 18, and the actual coordinates of that point are 0, 18. To find a, all we have to do is replace every single x we see by 0, and the y we see by 18. Here's what that would look like, and I'll just write using the point 0, 18, and replacing every x we see by 0 and y by 18, this equation becomes 18 equals to a times 0 plus 1 times 0 minus 2 times 0 minus 3. That becomes 18, which equals to a times 0 plus 1, which is just 1, times 0 minus 2, which is negative 2, times 0 minus 3, which is negative 3. Carrying on, we have 18, which equals to a times 1 times negative 2, which is negative 2, times negative 3. So that's just 6. In other words, we have 18, which equals to a times 6. Now, dividing both sides of this equation by 6 leads to 18 over 6 equals to a. In other words, 3 equals to a, or simply a equals to 3. And we now have the value of this polynomial's leading coefficient. Finally, combining these two results, we can go ahead and state this polynomial's equation in its factored form. And we can write that y equals to 3 times, in parentheses, x plus 1 times x minus 2 times x minus 3. And that's the answer. And I'll just go ahead and box that. There we go. And underneath that, I'll write factored form. Factored form. Done. Now, I should say that in many exams, we'll be able to stop here. Indeed, we'll often be asked to find a polynomial's equation in its factored form. But if ever we were also asked to write its equation in standard form, like what we have in yellow at the top of the page here, then all we would have to do is multiply all of these parentheses together. And in fact, I'll do that in the bottom right-hand corner of the page here, starting from the result we just found, so that was y, which equals to 3 times x plus 1 times x minus 2 times x minus 3. I'll start by multiplying these first two pairs of parentheses together, and that leads to 3 times x squared minus x minus 2, and that still multiplies x minus 3. I now multiply these two pairs of parentheses together, which leads to 3 times x cubed minus x squared minus 2x minus 3x squared plus 3x plus 6. I now gather all the like terms inside of this pair of parentheses, which leads to 3 times x cubed minus x squared minus 3x squared, so that's minus 4x squared, minus 2x plus 3x, so that's plus x, and finally we have our plus 6 at the end here. Last but not least, we distribute the 3 across the parentheses, leading us to y equals to 3x cubed minus 12x squared plus 3x plus 18. And that's this cubic polynomial's equation written in standard form. And I'll go ahead and write that as well. That's the standard form of this polynomial's equation. Done. And there we have it. That's it for this first example in which I show how to find a cubic polynomial's equation in its factored form as well as its standard form using its graph. And that's it for this tutorial.